Welcome to SingleCrystal 4. In this tutorial we're going to take a look at stereographic projections of lattice planes, vectors, their poles and traces. And we call the resulting display in SingleCrystal a stereogram, and this is handy for showing your current orientation and also for investigating angular and symmetry relationships. Now before we start, we'll have a quick recap on what a stereographic projection is. It's a circular, two-dimensional diagram that shows the arrangement of directions in space. It's very handy because it allows us to quickly see symmetry relationships, and it provides a fairly undistorted representation of the angles behind different directions. Certainly much less distorted than other kinds of projections, for example map projections and polar projections. The way the stereographic projection works is really quite straightforward. We need to consider an imaginary sphere, and cutting that sphere through the centre horizontally is an equatorial plane. We call this the projection plane, and that's where our stereographic projection is going to be constructed. We need to imagine a direction in space. And remember, we're not interested in lengths, we're only interested in directions. This direction is indicated in the diagram here as the vector OP. It actually continues to infinity out of our imaginary projecting sphere, but we're only interested in where it hits the surface of that sphere. And as soon as it hits the surface of the sphere, we reflect it downwards to the south pole of our imaginary projecting sphere. On its route down south, it passes through our plane of projection, and we mark that point. It's shown here as P prime. And that is what is shown on the stereographic projection. So just to recap, we have directions in space, we have an imaginary projecting sphere, and then through the center of that projecting sphere we have an equatorial plane. That plane is going to become a circle when we remove the sphere, and the points on that plane are our stereographic projection. Okay, let's get cracking with SingleCrystal 4. Here we have a simulated diffraction pattern for a cubic crystal, and we want to take a look at its stereographic projection. If the stereogram pane isn't already visible, we go up to the window toolbar and we can click the stereo button to make it visible. And here on the right hand side, by default, we see three directions in space. These are the reciprocal unit cell vectors A star, which is the normal to the plane 100, B star, which is the normal to the plane 010, here coloured green, and C star, which is the normal to the plane 001, shown here in blue. Of course, we can customize this, and we'll do that later on, but this is a two-dimensional representation of our three-dimensional vectors. And of course, in SingleCrystal, we are dealing with images, two-dimensional images of diffraction patterns. Diffraction patterns, of course, are generally recorded in 2 dimensions, so that's what we're showing. Now, we can, at the very basics, we can look at these 3 vectors as our orientation guide. And if you rotate the diffraction pattern, you'll see that the vectors rotate. Now, when you rotate your diffraction pattern itself, we tend to use quite small angles, so you don't get lost in reciprocal space. But if you want to make very large changes to your orientation, you can move the mouse over the stereographic projection. Notice that as I do this, I get a temporary measurement showing my orientation. For now, we could just click and drag, and now we're moving our reciprocal lattice vectors. And as we do that, of course, the diffraction pattern on the left updates. Quick tip, if you want to set any of these reciprocal lattice vectors as your view direction, just move the mouse pointer over the direction so that the popover appears, and we'll click Set View. And now we're looking down 100. We're now going to have a look at customizing that stereogram. And to do this, I'm going to make a little bit more space in my window by hiding the diffraction pattern. Quickest way to do that, of course, is just to click its close box. Now we have an inspector for the stereogram, and let's click on the inspector button to make that visible. If you click anywhere in the stereogram pane, the inspector will appear, and you'll see that it's divided into two panes. We have a projections pane that allows us to change the display of the stereographic projection, and then we have a poles pane. So if we go back to our 100 pole here, we've already set this as our view direction, but we can also edit the pole. So let's click on edit pole, and that takes us to the poles pane, and we can see our 3 poles visible. By the way, when we say pole, we're just referring to that little circular spot. It's the projection of a direction on this projection plane. Now for each pole we can show its trace, and by trace I mean this red circle around the edge. This is the locus of all points that are at 90 degrees to the 100 lattice plane vector. Now if you turn on the trace, you'll see that's visible. If you rotate slightly, then you'll see that what we have here is a great circle. You're not limited to a great circle. If you want to show all points that are less than 90 degrees away from 100, then we can edit this angle. So let's try 45 degrees. And now we have what's called a small circle. Now if you don't believe me, we can read off the angles using the StereoNet. So the StereoNet is in 10 degrees, so we've got 10, 20, 30, 40, 45 degrees all around here. And incidentally, you can use this dial around the edge to rotate the StereoNet. We're not rotating the crystal. You can see that the reciprocal lattice vectors are fixed, but we are rotating the StereoNet. And we can customize that StereoNet using the projections inspector. We can turn it on and off. We can turn off the rotation dial, we can control the minor traces, and we can change the coloring of the traces. We can also reset the angle of the net here. I'm going to go back to the poles inspector. We're going to turn off this small circle trace, and we're going to customize by adding another pole. So let's add 111. I've just double clicked in the list and we've added a new pole of the form 111. Notice the type column here. This represents a lattice plane. You can see we have a plane. The icon shows a plane with a vector coming out of it. So what we just added is a lattice plane normal. You can see that from the curved brackets around 111. And the icon represents a plane with a normal coming out of it. Now there's another type of direction in the crystal called a lattice vector, and if you click on type we can toggle between a lattice vector and a lattice plane. Notice that in the stereographic projection here, lattice vectors have square points and lattice planes have circular points. We're going to be just concerned with lattice planes at the moment. Of course, for a cubic crystal, lattice vectors and lattice planes point in the same direction, but for most crystals in the universe which don't have cubic symmetry, that won't be the case. Now we can turn on the trace and we can change the color very easily. If you go up to this Actions menu, you'll see that we have some options for showing groups of planes. So I'm going to go down to the Show Poles to Max Index and add all planes with HKL 0, 1 or -1. That's a lot of planes. Now if I go to the Projection Inspector, I can turn on South projections, so this will show all projections that occur in the southern hemisphere as well as the northern hemisphere. And let's just set our view direction to down the c-axis. There we go. Okay, we might want to turn off the south projections now. And we'll go back to the poles inspector, and we've got an awful lot of poles here. So the first thing I'm going to do is I'm going to colour these by symmetry. Now we can also group these by symmetry. Now we have 3 disclosure groups in our list. So the 001 type planes, notice the squiggly brackets here, the curly brackets indicate a set of lattice planes that are related by symmetry. So the 001 type planes, and we can toggle these on or off. And if we open up, click on the disclosure triangle to open up the group, you can see we have the 001 type planes in red, the 011 planes in green, and the 111 planes in blue. And we can turn on their traces by clicking on the checkboxes. We maybe want to tidy up the display at this stage. We don't need our StereoNet anymore. Maybe we want to make the traces a little bit thicker. And we can make the poles bigger as well. And you can change the font size. This is rather a pretty display, and we might want to copy it to another program. And we can do that. We can export the graphics, or we can copy them to the clipboard. And a quick way of doing that is simply to right-click in the stereogram pane, and we can copy or export graphics. If we choose the export option, then we have a choice of vector graphics or pixel graphics. And for pixel graphics, the best options are to use TIFF or PNG, and you'll notice that you have the option of a transparent background, and you can choose the output size for your graphic. So you can get very beautiful stereographic projections of planes, vectors, and their traces.